Hi, welcome to the fourth algebra tutorial, simultaneous equations. This is a fairly easy tutorial, but you do need to have gone through the first three algebra tutorials titled Basic Algebra, Factorization, and Quadratic Equations. You also need to be familiar with your grade 10 work. In all of the examples we have encountered thus far, we have had to solve for only one variable. For example, x or x squared or a or z or y or theta. What happens when we have to solve for more than one variable? For example, x plus 2y. How do we solve for x and for y? It is at this point that we introduce a concept called simultaneous equations. Simultaneous equations are essentially the use of multiple equations to solve multiple variable type problems. Let us look at the following example. We want to solve for x and y, and we have the following equations. X plus 4y is equals to 9 and 3x minus 6y is equals to 18. I'm going to leave the x plus 4y equals to 9 as x is equals to 9 minus 4y. All I've done is taken that 4y from the left hand side to the right hand side. In essence, what I've done is I've isolated x. Because I've isolated x from the one equation, I'm going to do it from the second equation. That means that 3x will equal 18 plus 6y. That means that x will equal 6 plus 2y. I've divided through by 3. That means that from equation 1, x is equals to 9 minus 4y, and equation 2, x is equals to 6 plus 2y, I've isolated x in both of them, and x is the same. X represents the same variable. That means that 9 minus 4y is equals to 6 plus 2y. Because they are both equals to x. That means that minus 4y minus 2y is equals to 6 minus 9. That means that minus 6y is equals to minus 3. Y is equals to minus 3 divided by negative 6, which is equals to positive 1 over 2. That is my y value. Substitute that into either of the equations to get my x value. I'm going to substitute it into the first equation. That means that x plus 4 times a half is equals to 9. That means that x is equals to 9 minus 2, which is equals to 7. Hence, x is equals to 7 and y is equals to a half. Take note that because I had two variables, I needed two equations at least to solve for both of the variables. I want you to now have a go at the following. The first simultaneous set of equations I gave you to do read x plus y is equal to 5 and x squared plus 8y squared minus 15x is equal to 6. The first thing I'm going to do is I'm going to get either x or y in terms of 5 and the other variable. I'm going to make this x, that first equation, x is equal to 5 minus y, or minus y plus 5. I'm then going to plug this in to wherever I've got an x value in the second equation. This will read minus y plus 5 squared plus 8y squared minus 15 multiplied by minus y plus 5 is equal to 6. Can you see that all I've done is take away my x's and put it in terms of y? this will read y squared minus 10y plus 25 plus 8y squared plus 15y minus 75 is equal to 6. Y squared plus 8y squared is 9y squared, minus 10y plus 15y is plus 5y, plus 25 minus 75 minus 6 is going to give me minus 56, which is equal to 0. Now this question unfortunately cannot be factorized, hence we are going to have to use the quadratic formula. Remember that the quadratic formula reads x is equal to minus b plus minus b squared minus 4ac over 2a. Except we don't have x, in this case we've got y. Is it any different? No. Y is equal to minus b plus minus square root of b squared minus 4ac over 2a. That means that y is going to equal minus 5 plus minus square root of 5 squared minus 4ac over 2a. The one possible answer I'm going to get is y is equal to minus 5 plus square root of that over 18, which is going to give me 2.23, and my other option is y is going to equal negative 2.79. All you've got to do is plug this into the calculator and look at the answer that it gives you. This is only my y values. Remember that I needed to solve them simultaneously. I needed to find my x and my y values that made that make sense. What I'm going to do is I'm going to take these two y values and I'm going to plug it into my easier equation in place of y to get my corresponding x. In this case, x will equal minus 2.23 minus y plus 5, which is going to equal 2.77 rounded off to 2 decimal places, or x is going to equal negative 2.79 plus 5, which is going to equal 7.79. So my one set of values are x is equal to 2.77, y is equal to 2.23, and my other set of values are x is equal to 7.79, y is equal to negative 2.79. The next one I gave you to do read x minus y minus 7 is equal to 10, and 3x squared plus 8y squared minus 15y is equal to 7. This being equation 1 and that's equation 2. Again, I'm going to start by my simpler equation and I'm going to get it in the form x is equal to or y is equal to. I'm going to turn this into x is equal to, take the y across, it becomes positive, y 10 plus 17, 10 plus 7 becomes 17. I'm going to plug this in to wherever I've got an x. That will become 3x squared or 3y plus 17 squared plus 8y squared minus 15y is equal to 7. That means that 3y squared plus 102y plus 867 plus 8y squared minus 15y is equal to 7. That translates to 11y squared plus 87y plus 860 is equal to 0. You can try and factorize this. It will be much easier if you use the quadratic formula. Even though there are big numbers in it, you do have a calculator. Y is equal to minus b, which is minus 87, plus or minus square root of b squared, which is 87 squared, minus 4ac over 2a, which is 2 times 11. Now the problem is 4 times 11 times 860 is going to be greater than 87 squared, which means that for this here there is no solution, because we cannot have the square root of a negative. Your calculator will tell you something like syntax error or math error. In fact, I think most of them should say math error. That means that we cannot solve these two equations. X minus y minus 7 is equal to 10, and the next one, 3x squared plus 8y squared minus 15y is equal to 7. These two equations cannot be solved simultaneously. Number 3 is an interesting one. It reads 8x plus 9y is equal to 20. That's equation 1. The second equation reads 16x squared plus 18xy minus 20 is equal to 14x, and that's equation number 2. Now you can make this 8x is equal to 20 minus 9y, or the other way around, get x on its own and then plug it in there. That's fine, you'll still get to the same answers I'm about to get to. But look at this here, 16x squared plus 8xy, sorry, plus 18xy. What if I take out a common 2x? Wouldn't that be 8x? 2x from 16x squared goes 8x times plus 9y minus 20 is equal to 14x. Why did I do that? Look at this. 8x plus 9y is equal to 20. So instead of 8x plus 9y, can't I write in 20 times by 2x minus 20 is equal to 14x? That means that 40x minus 14x is equal to 20. That means that 26x is equal to 20. X is equal to 20 over 26. Or you could have also said x is equal to 10 over 13. That's only my x value. I still need to find my corresponding y value. I'm going to plug it in there. That will become 8 multiplied by 10 over 13 plus 9y is equal to 20. This will become 80 over 13 plus 9y is equal to 20. 9y is equal to 20 minus 80 over 13. That means that y on its own will equal 20 minus 80 over 13 divided by 9, which is going to equal 1.54, rounded off to 2 decimal places. That means my x value is 10 over 13 and my y value is 1.54. That's my x, that's my y. This was pretty easy, wasn't it? And that brings us to the end of simultaneous equations. Go through the exercise that I left for you in the workbook before progressing with the next tutorial. Just a quick word on the technique I was using to solve simultaneous equations. It is the technique that I prefer to use. You may use any of the different techniques that you are more comfortable with. Different schools and textbooks and study guides use different techniques. As long as you understand the basic principle behind it, go for it.